Hey everyone, in this video what we're going to do is we're going to solve the following quartic equation using Descartes' method. Now before we begin, what we're going to do is just give a basic introduction to Descartes' method and sort of show you how and why it works. Now we're going to begin with the depressed quartic equation. A quartic equation is in depressed form if it doesn't include the cubic term, but notice, if we actually already had a quartic equation which had a cubic term, we could eliminate that cubic term by making the following substitution: x is equal to t minus b divided by 4. Now it's quite a lengthy multiplication, so for the sake of keeping this video as short as possible, we will begin with the depressed equation. What we want to do is we want to set the coefficients of our quartic equal to the following system of equations, and substitute these values for our coefficients into our depressed quartic equation. If we do that and we carry out the following multiplication, we get x to the 4th power plus vx squared plus wx squared minus u squared x squared plus uwx minus uvx plus vw is equal to 0. Now if we rearrange our equation in the following way, The reason for doing so is it makes the next step a little bit clearer. What we're going to do is we're going to factor an x squared out of the first two terms, and we're going to factor a w out of the last three terms. Doing so, we have x squared times x squared minus u squared plus vx squared minus uvx plus w multiplied by x squared plus ux plus v is equal to 0. We can actually rewrite x squared minus u squared as x minus u multiplied by x plus u, and we can actually also factor a vx out of the third and fourth term. Doing so, we end up with x squared times x minus u times x plus u plus vx multiplied by x minus u plus w times x squared plus ux plus v equals 0. And we can actually factor out an x minus u from the first and second term, so that we end up with the following: x minus u times x squared times x plus u plus vx plus w times x squared plus ux plus v equals 0. Now, if we factor out an x from x squared times x plus u plus vx, and we distribute one of the x's, we end up with x times x minus u multiplied by x squared plus ux plus v plus w times x squared plus ux plus v equals 0. Now notice, we have a common factor in both of our two terms of x squared plus ux plus v. If we factor this out of each of the two terms, we have x squared plus ux plus v multiplied by x times x minus u plus w, and this is equal to x squared plus ux plus v times x squared minus ux plus w. So essentially what we've done using our system of equations is we've reduced our quartic equation to the product of two quadratic equations. And if we know the values of u and v and w, we can easily solve these two quadratic equations using the quadratic formula. So what we're going to do is we're going to figure out what v and w are, and this will in turn allow us to figure out what u is, and ultimately substitute these values into our two quadratics and find the roots of our quartic equation. Now, if we multiply our first equation by u and add it to our second equation, we get the following system of two equations: 2wu minus u cubed is equal to pu plus q, and vw is equal to r. If we solve for w in our first equation, we can then substitute this value into our second equation to get v. Doing so, we have w is equal to u cubed plus pu plus q divided by 2u, and we have v is equal to 2ur divided by u cubed plus pu plus q. Now remember, we know the values of p, q and r. All we need to do is figure out what u is now. Well, if we substitute our expressions for w and v into our first equation, v plus w minus u squared is equal to p, we get the following equation. In u. We have u to the 6th power plus 2p u to the 4th power plus p squared minus 4r multiplied by u squared minus q squared is equal to 0. But right now you might be a little bit confused. We started with a quartic, and we've went through all these steps to end up with an equation in u raised to the 6th power. Well, what we can actually do is make the following substitution. We can set y to be equal to u squared, and then substitute this into our equation in u to get the following cubic equation: y cubed plus 2py squared plus p squared minus 4ry minus q squared is equal to 0, which we can solve using Cardano's methods, or by inspection, or simply by factoring it. So if we know what y is, then we know what u is, and we can substitute this value of u into our expressions for w and v, so that we can figure out what w and v are. And if we know what u, v and w are, we can essentially figure out what the roots are of our two quadratic equations: x squared plus ux plus v times x squared minus ux plus w, and ultimately figure out what the roots are of our quartic equation. So now that we know what Descartes' method is, let's apply it to our quartic equation in the top left hand corner. For our specific problem, P is equal to minus 14, Q is equal to 5, and R is equal to 30. If we input these values into our cubic equation in the top right hand corner, we have y cubed minus 28y squared plus 76y minus 25 is equal to 0. Now we could solve this using Cardano's method, but I happen to know that one of the solutions is that y is equal to 25. Now that we know what y is, we know what u is. Because we set y squared to be equal to u, so u is equal to the square root of y, which is equal to 5. And this in turn allows us to figure out what w and v are. We have w is equal to 6 and v is equal to 5 if we input all of our values for u, r, p and q into our formulas for w and v. And now that we know what u, v and w are, we can input these values into our two quadratic equations, x squared plus ux plus v times x squared minus ux plus w, to get x squared plus 5x plus 5 multiplied by x squared minus 5x plus 6 equals 0. And we can easily solve these using the quadratic equation. In doing so, we get the following 4 roots. And these are the 4 roots of our original quartic equation. And that's the final answer to our problem. Thank you very much for watching. I hope you found this content useful. If you have any questions or problems you'd like to see get solved in future videos, let me know in the comment section below. I hope you have a great day.